Welcome back. Today we're going to be talking about the real number system. This is part 2 of our videos on the real number system. So if you haven't watched part 1, you want to go ahead and do that first. But if you have, let's go ahead and get started right now. Here we are at part 2 at our look at the real number system. If you haven't watched part 1 of the videos, you want to go ahead and back and take a look at that. However, if you have watched part 1, we're going to go ahead and take a look at part 2 right now. Here we are at example A. And example A says, what subsets does negative 6 belong? So we're going to have to take our negative 6. We're going to have to figure out which subsets it belongs into. So I'm going to take a look at my negative 6. I've got no fractions, no decimals. So I know that it's at least rational, but it's negative, so I know that it can't be a natural number. It's not 0, so I know it's not whole. So I know that negative 6 is an integer. But I got to write not just integers, because it doesn't ask me what one subset describes it the best. It tells me to list all of the subsets that it belongs to. So I know that it's a real number, so I'm going to write down that it's real. I can see that it is also a rational number, because if it is an integer, it is a rational number, so I know that it meets both those categories. So I'm going to say that it is both rational and an integer. So when it tells me which subsets that it belongs to, I have to write down all the subsets. I can't just write down the one that is most descriptive of it. So since an integer is also a rational number, or for another example, looking at your real life example from part 1, if it is in the 8th grade, it is also in the middle school in this case. So negative 6, real, rational, and an integer. Let's take a look at example B. So here we are at example B. It says, example B, what subsets does the square root of 49 belong? So I'm not going to just take the square root of 49 and try and figure out where that belongs. I have to simplify it. So I know the square root of 49 is equal to 7. So I'm going to try and figure out where does 7 belong. I've got no decimals, I've got no fractions, I've got no negatives. It's not 0. It is one of my counting numbers, so that I know it goes in the box that says natural numbers. But I can't just write natural numbers, because we're not just looking for the most accurate set that it belongs to. I'm looking for all of the subsets that it belongs to. So I know, starting off, it is a real number. All the numbers that we're talking about are real. 7 is definitely on the number line, so it is a real number. I see that I put it in the natural box, so it is going to be natural. But all natural numbers are also whole numbers. All whole numbers are also integers. And all integers are also rational numbers. So I have to write down all 5 of those answers. It is not just one answer. You cannot just say that it is natural and be done with it. You have to write down all of the subsets that it belongs to. So in this case, it's natural, it's whole, it's an integer, it's rational, and it is real. Now, let's take a look at a practice problem for you to try on your own. So here we are at practice number 1. It says, what subsets does pi belong to? So I want you to take a look at pi, think of where it belongs, and then I want you to write down all the subsets that it belongs to. So go ahead and pause the video now, try this one on your own, then press play again to see if you are right. All right, how did you do? Did you figure out that the number was both irrational and real? So you make sure that you have both these answers down. When it asks what subset does it belong to, it is both an irrational number and a real number. It's not natural, it's not whole, it's not an integer, it's not rational, because it's going on and on forever and never repeating. So now let's take a look at practice number 2. Here we are at practice number 2, and it says, what subsets does 0 belong to? So you're going to try this one on your own. So go ahead and pause the video now, and then complete the problem, then press play again to see if you are right. How did you do? Were you able to list all the subsets that 0 belongs to? Yes, 0 is a whole number. However, whole numbers are also integers. They are rational and they are real, so you got to make sure that you have all 4 answers written down. You cannot just write whole number. If you did that, great. If not, go ahead and make sure that your paper looks like mine, and let's go on to the next one. Here we are at example C. Example C says I've got to circle all of the whole numbers. So I'm going to take a look, find the numbers that I know are whole numbers, and then see if I can work from there. So I've got 0. I know for sure that is a whole number. It is the only whole number that is not a natural number, the only whole number that is not a natural number, so 0, there we go. 15 is a natural number, so I know it is also a whole number. 3 is a natural number, so I know that's also a whole number. -8's got a negative sign, so it's not a whole number. That's not going to work. 3/4 is a fraction. Can't have fractions in whole numbers, so that's not going to work. Square root of 60 is an irrational number because it goes on forever and never repeats. 42 divided by 6 is 7. That is a natural number when I go ahead and reduce it, so I know that's going to be a whole number. And then the square root of 81 is 9, and 9 is also a natural number, so that I know that it is a whole number. So I've circled now all of the numbers that are whole numbers. So if I see a question like this, I got to make sure that I get all of the numbers. If I don't get all of the numbers, I won't get full credit. So let's go ahead and practice that now on your own. So here we are at practice number 3. It says circle all of the rational numbers. So you are going to look for all of the numbers that are rational. You're going to go ahead and circle them all. I want you to try that now on your own. So press pause on the video and then press play again to see if you are right. How did you do? Did you circle all of the correct answers? The only numbers that you should not have circled are pi and the square root of 22. Square root of 22, once you put that 22, put that in your calculator and hit the square root button, it goes on forever, never ends, doesn't repeat. It's not a perfect square. Pi, obviously the symbol of irrational numbers, is not also going to be a rational number, so you should have just the number circled that we have. If your paper looks like mine, great. If not, go ahead and make sure that it does now, and then let's move on to the next one. Here we are at example D, and example D says determine if these products and sums are rational or irrational. So we're not trying to figure out if the number is what the answer is. We're not looking for 5 or 26 or square root of 3. We're not looking for an actual answer. We're just trying to determine is the answer going to be rational or irrational. So our first example, we've got a rational number times an irrational number. And if I were to do that, if I were to hit the square root of 14 and then I multiplied by 2 in my calculator, I would get a decimal that goes on forever and never repeats. So my answer would be irrational. And this is the key. Anytime that an irrational number is involved, your answer is going to be irrational. So I've got a rational number in number 1 and an irrational number 2, the second number there, so they are both going to give me an irrational answer. For the second one, I've got a rational number and a rational number. Now don't worry, I'm not asking you to add fractions. I know we're not big fans of that, but I'm just looking for if it's rational or irrational. Since I've got 2 numbers that are rational, my answer will be rational. And then again there at the bottom, I've got an irrational number and a rational number. So irrational gets in the mix and it messes everything up, and our answer is going to be irrational. So anytime that you see an irrational number in the problem, you know that the sum or the product is going to be irrational. Now let's try some practice problems on your own. So here we are at practice number 4, and it says determine if these products and sums are rational or irrational. So now you're on your own. You're going to try these 4 on your own and determine if the answer is rational or irrational. I'm not looking for the actual mathematical number answer. I just want to know whether it's rational or irrational. So go ahead and press pause now, try the 4 problems on your own, then press play again to see if you are right. How did you do? Did you get the answers correct? Make sure that your paper looks like mine. If it doesn't, go ahead and fix it now. And then let's go on to the next one. So here we are at example E, and example E has a picture for us, and it has whole numbers inside integers. So based on our picture, we see that all whole numbers are also integers. So everything that's a whole number is also an integer. So some examples of whole numbers are 0, 8, 15. Are these the only choices that I could have picked? No, but they're a good representation, and I always want to make sure that when I have whole numbers, I can write 0. And these are also integers. So every number that is a whole number is also an integer. However, some integers that are not whole numbers would be examples like -5, -9, -47, numbers that have negatives. So there are numbers that are integers that are not whole numbers. However, all whole numbers are integers. Let's take a look at another example. So example F says, based on the picture, we see that the set of whole numbers and irrational numbers do not overlap. So they're not overlapping in any way. Some examples of whole numbers, we've got 0, 9, 27. Some examples of our irrational numbers are like pi, the square root of 12, which is a non-perfect square, and 0.153, on and on and on, and never repeats. So in this picture, we can see that whole numbers and irrational numbers are not related. They are not the same. So every whole number is not irrational, and every irrational number is not a whole number. So now let's see if you can do some practice on your own. So here we are at practice number 5, and it says, which shows the relationship between rational numbers and integers. So I want you to go ahead and take a look at the pictures. I want you to determine which one is the correct relationship, and then do it yourself. You want to go ahead and pause the video now, and then press play again to see if you are right. So how did you do? Were you able to figure out the correct answer? The correct answer shows that all integers are rational numbers. That is the correct picture up there, so make sure that you circled it. If your paper doesn't look like mine, go ahead and fix it so that it now does. This brings us to the end of this video, so if you like this video, go ahead and throw us a thumbs up. If you love this video, go ahead and throw us a sub, and we will see you in the next one.